Bismillahirrahmanirrahim. My name is Engineer Waqas Abdul Salam. I belong to Lahore. I am serving as Assistant Director Electrical in Government Center of Excellence for Training and Development, GSTC, Moghalpura, Lahore. I want to give you my introduction of career. I have joined TEPTA in November 2016 as a principal in Government Technical Training Center, District Jail, Gujarat. During principalship, my major responsibilities are administrative duties, financial duties, and academic monitoring services. So, admission of my institute was 100%. Result of the institute was also 100%. Cleanliness and maintenance standards were remarkable, and our discipline was excellent. In addition to that, I have planted 4,000 plants within the premises of my institute to provide a beautiful learning environment for the trainees. In addition to that, I have performed my duty as a master trainer of digitized monitoring and evaluation software. I served here for a period of about 7.5 years. After that, I transferred to research and development section, which is called as R&D section in TEPTA Secretariat, Lahore. During my posting in R&D section, I have conducted primary and secondary research on the feasibility analysis of the establishment of new institutes and upgradation of the existing institutes and gap analysis of DA courses. In addition to that, TNA training need assessment process was also conducted. So this period was very helpful for me. I have served here for a period of about 6 months. After that, I transferred to Government Center of Excellence for Training and Development, GSTC, Moghalpura, Lahore, as a Assistant Director. During my posting in GSTC, the scope of my duties changed a little bit. I became the lead trainer or master trainer in GSTC. I have conducted the trainings like skill upgradation training, which is the training of teaching staff of TEPTA. Secondly, the GIG training of the overseas returnee. The first training which I conducted here was solar PV system overseas returnee training. It was a batch of 30 students. All the students who got enrollment, they all got employment in the field of solar industry. After that, second batch of GIG was conducted and the same result was repeated. In addition to that, in summers, industrial trainings are being conducted in COE. These trainings are conducted on the floor of industry. So the major industries which collaborate with us in this regard are L Private Limited, Unique Solar Private Limited, Sky Power Private Limited, Creative Electronics Private Limited, Honda Private Limited, and etc. These industries not only provide their floor for the training of the teaching staff of TEPTA, but also these industries provide job opportunities for our trainees. So it is very helpful process, and I am the lead trainer and master trainer of these trainings in the field of solar PV course, electrician trade, electrical trade, and renewable energy sources trade. So it is the whole my journey in TAPTA. Now I want to introduce my academic background. Basically, I am electrical engineer. I have completed my BSc Electrical Engineering degree in 2012 from Punjab University, Lahore. After that, I enrolled in MS Electrical Engineering program, and I obtained first position in Electrical Engineering department in 2015-16 batch. After that, I enrolled in PhD Electrical Engineering program, and currently I am the research scholar in the field of electrical engineering. So what I have learned from my education, I have applied this knowledge and skill to my employment. My major objective is that to provide a quality of education to our trainees. Recently, I have participated in TAPTA Rehan Foundation Artificial Intelligence Teachers Training Program, and I have assigned a task to watch a tedx video and to prepare a brief review presentation on this video, on this tedx talk, and to present a video. So let's start to the tedx video, brief review. So this tedx task basically titled by the Neuroscience Pathways from Lab to Classroom by Dr. Judy Wills. Dr. Judy Wills, a neurologist turned educator, shares insights from neuroscience into classroom behavior and learning challenges. She observed an increase in students' referrals for behavioral disorders without an actual increase in diagnosis. This led her to explore the connections between brain science and classroom experiences, prompting her to become a teacher to apply neuroscience research directly in education. So, the neuroscience of stress in learning. Willis explains that sustained boredom and frustration in students cause high stress, activating the amygdala, the brain's emotional switching station. When stressed, the amygdala blocks information from reaching the higher reflective brain, prefrontal cortex, causing students to react through the lower reactive brain. These reactions manifest as fight, flight, or freeze behaviors, often misinterpreted as behavioral disorders, but actually automatic stress responses. The impact on academic performance. Stress not only affects behavior but also impairs cognitive functions like memory and learning. Brain imaging studies cited by Willis show that stressed students have significantly less prefrontal cortex activity, which correlates with poorer memory performance. This creates a cycle where students give up effort, developing a fixed mindset, believing their abilities are limited, except in contexts like video games, where the brain remains engaged despite frequent failure. Video games as a model for engagement. Dr. Willis highlights that video games naturally motivate students through three key elements: achievable challenges, opportunities to make predictions, and immediate feedback. This model engages the brain's dopamine system, fostering perseverance and a growth mindset. Unlike passive classroom instruction, video games stimulate intrinsic motivation by rewarding incremental progress and sustained effort. Classroom applications and strategies. Willis advocates for incorporating game-like elements in education to combat boredom and frustration. Practical strategies include differentiated achievable challenges, frequent formative assessments, immediate feedback, and visually tracking progress. These approaches help build confidence, resilience, creativity, and deeper learning by engaging the brain's reward system and supporting reflective thinking. This TEDx talk effectively bridges neuroscience and education. So, the most important thing is that Willis advocates for incorporating game-like elements in education to combat boredom and frustration. He suggests that when we introduce the elements which like the game and to obtain a learning education process through the elements of game, then the process become very easy for us. The things which we consider are very difficult and which we consider is not graspable for us. So when we include the elements of gaming, when we include the simple elements which solve the complex issues or complex problems into simple one, then the our process becomes very easy. So overall learning process become more easy and approachable. So she explained that when students face sustained boredom or frustration, it activates the amygdala, a key brain area involved in emotional processing and stress response. The amygdala acts as a switching station that determines whether information is routed to the higher order thinking brain or stuck in a reactive state controlled by lower brain. When stress is high, the amygdala blocks access to the reflective brain, causing students' behavior to be controlled by reactive impulses: fight, flight, or freeze. These automatic reactions help explain classroom disruptions or inattentiveness. This stressed state not only alters behavior but also hampers cognitive skills essential for learning, such as memory and problem solving. Dr. Willis presents brain imaging studies showing that stressed children have less prefrontal cortex activity, correlating with lower memory retention. Under stress, many learners develop a fixed mindset, believing their intelligence and abilities are static, which reduce persistence after failure. So, Doctor Judy Willis' TEDx talk delves deeply into how neuroscience explains common student behavior issues seen in classroom as natural brain responses to stress rather than systematic problem. She begins by noting the rise in student referrals for disorders like ADHD and oppositional defiant disorder, but observes the actual incidence rates did not increase. Instead, the increase reflected how classroom stresses, especially boredom and frustration, affect children's brain function and behavior. To counter this, Doctor Willis draws attention to the way video games engage the brain. Video games motivate sustained effort despite frequent failure by providing achievable challenges, constant opportunities to predict outcomes, and immediate feedback on performances. These elements stimulate dopamine release, which promotes motivation, curiosity, and learning. Unlike traditional passive classrooms, video games continuously engage the brain's reward system, encouraging perseverance and learning from mistakes. Finally, she suggests practical ways for educators to apply these findings by creating classroom conditions that mimic this video game model. Recommendations include differentiating instructions to provide appropriately challenging tasks, frequent frequent assessments with quick feedback, and helping students track their incremental progress. This approach fosters a growth mindset, confidence, and creative problem solving, effectively helping students overcome stress-related learning barriers and fully engage their reflective brain for deeper learning. Thus, the core message is that the understanding brain science can transform how teachers approach student behavior and motivation, providing strategies to create engaging, stress-reducing learning environments where all students can thrive cognitively and emotionally. So, this is the view of Dr. Judy Willis. Now, my views on this video are that you might, I might appreciate Dr. Willis' reframing of disruptive classroom behaviors such as acting out, zoning out, or withdrawal as natural stress responses rather than deliberate misconduct or purely psychological disorder. This perspective can be empowering for educators, helping them approach behavior with empathy and scientific understanding. I could highlight how this align with our experience in technical training or curriculum development, emphasizing that recognizing brain-based causes can reduce misdiagnosis and improve intervention strategies. Reflecting on my view, I may agree that modern education often overloads students with content and standardized testing, inadvertently increasing boredom and frustration, as well as notice. I could discuss the urgent need for more engaging differential instruction that addresses diverse learning paces and style, something essential in vocational and technical education where practical engagement is crucial. This approach not only supports learning outcomes but also fosters emotional well-being. Her video game model as a learning tool, I might find the video game inspired model my achievable challenges, prediction, and immediate feedback highly relevant, especially given my involvement in training and use of digital tools. I could urge that incorporating gamification, interactive simulations, and real-time feedback in technical training enhances motivation and retention. I view might stress that motivation driven by intrinsic reward is far more sustainable than extrinsic reward like grades or prizes. So, application of neuroscience to curriculum development. From my perspective as a curriculum developer, I can express enthusiasm for using neuroscience findings to refine teaching strategies and assessments. I might discuss how formative and scenario-based assessments, as I develop them, effectively provide the frequent feedback and incremental progress awarenesses by Willis advocates. You may see this is an opportunity to innovate training programs that better engage learners and build resilience against setbacks. Similarly, there are challenges are there and future directions are also. Finally, I can reflect on challenges in fully integrating neuroscience into classroom practice, such as teacher training, resource constraints, and system rigidity. I may suggest ongoing professional development for educators on brain science, more technology integration, and policy shifts that prioritize students' engagement and mental health. I view might underscore the importance of research practice collaborations, mirroring Willie's own career shift from the neurologist to teacher. In summary, my detailed views could combine professional insight with acknowledgement of practical implications and challenges of applying neuroscience to education, highlighting the potential for transformative improvements in student motivation, engagement, and learning success. So, it is all about my personal point of view about this tedx video. I have found this video very helpful and I want to implement her ideas in the field of technical and vocational education in which we can apply these techniques and to get a good outcome from our trainees. So it is very helpful. And I have given the whole review presentation of this TEDx video. And now I want to close it. Thank you very much. Okay.